Okay, my friends, if somebody could let me know once I'm done this, there hasn't been enough time to kind of ask if this was worthwhile, because this is taking time, which is fine. I'm not complaining, but I will complain if nobody needs me to do this. Um, I'm going to, am I recording? Yes. I'm going to fill out this practice test I gave you so you can not only just kind of, excuse me, get the answers, but I'm going to try and think out loud as much as possible. Hopefully it'll help. Completing the square. First thing, it's in the a x squared plus bx plus c format, except the y is on the other side, which bugs me. So I'm going to change it. Y equals 3x squared minus 12x minus 8. Do you need to? No, because all you're doing is focusing on this, but this is what I want to do. Completing the square, I'm going to factor, take the numbers out of these first two terms, or at the very least, get rid of this. That's my goal, get rid of this. Who knows what it'll look like here, but it doesn't matter. I need to get rid of this. 3x squared minus 4x, and then I'm just going to leave that negative 8. If there wasn't a y, I'd probably put it on the other side of the equal sign, but I'm just going to leave it there for now. 3 times x squared minus 4x, negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. Now I've added, not only have I added the 4, 3 times 4 is 12, I've added 12. So I have to take away 12. If this was on the other side of an equal sign, I would add on one side, add on the other, but it's all on the same side, so I've got to keep it balanced. Complete the square. 3x minus, because that's that sign, the root of that is 2 squared, simplify that, negative 20. That's it. We've completed the square. We can see the vertex, the axis of symmetry, the line of symmetry. We can tell that it opens up. We could tell that before, but anyways, moving along to this next one. It's in a good format. It equals 0. It really doesn't matter. So this one, I kept numbers on the same side as the equal sign. Here, I'll move them over just to show a difference. First, I need to get that 4 out, and I'm also going to move well, if I move the 8 over, so it's 4x squared plus 12x equals 8. So I add 8 to both sides. This just sometimes, for some people, it just helps them focus. Keep this side over here. This is what I'm playing with. Take a 4 out, 4 times x squared plus 4 times 3 is 12, plus 3x equals 8. Did I do this right? Yeah. I think so anyway. Someone will tell me if I screwed up. X squared plus 3x, oh gross. 3 divided by 2 is 3 over 2. 3 over squared, sorry, 3 over 2 squared is 9 over 4. So this equals 8. Now what I've done is I've added 9, right? Because 4 times 9 is 36. 36 divided by 4 is 9. I've added 9 on the left, so I have to add 9 on the right. Complete the square. 4 times x plus the root of this, 3 over 2 squared equals 17. Running out of room. So we just need to bring this back. 4 times x plus 3 over 2 squared minus 17 equals 0. Part C. That negative 12 is over there. I'll just leave it over there. I don't care. Stay over there, negative 12. But I'm going to take the 3 out. 3 x squared minus 4x equals negative 12. Is this exact same as the one above? No, similar though. 3x squared minus 4x, negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4 equals negative 12. So I've added 12 to the left side, so I'm going to add 12 to the right side. Looks like it's going to cancel. 3x minus 2, negative there, square root of 4 is 2 squared equals 0. We're done. That's it. Because there's nothing to bring over. So it's done. Now down here it says for each of the above, I'll do this in a different color pen. Find the vertex, the line of symmetry, the maximum or minimum, direction of the opening, number of solutions, and the value of the discriminant. Well, so the vertex here is 2 and negative 20. The line of symmetry, I'm just writing answers all over. I didn't spend a lot of time formatting this test because I just wanted to give you practice. X equals 2. So whatever x equals, that's the line of symmetry. Is there a maximum or a minimum? Well, this thing is positive, so it has this shape. So it's going to have a minimum. So the minimum is -20. All y values are -20 or greater. Direction of opening, it opens up. I think we covered that. Number of solutions. Okay, so how do you know the number of solutions? Well, look at this. It's 2 and -20. So if you were to plot this vertex, so 2, 1, 2, and then down -20, somewhere down there, it opens up. It crosses the x-axis twice. So there are 2 solutions. And the value of the discriminant. I really didn't give a whole lot of room here, did I? B squared minus 4AC. You will get the quadratic formula. I'm not going to give you the discriminant. That's under the root sign in the formula. So B squared minus 4AC is B. Can you guys see this stuff? I hope not. Probably can. B squared is, we've got to go back up to here. So that's -12. Well, that's gross, eh? -12 squared minus 4 times A, which is 3, times C, which is -8. 12 squared is 144. 4 times 8 is 32. 3 times 32 is 96. And the reason it's positive 96, negative times a negative. Did I do this right? Let me just double check. 3 times 24, 48, 96. So the value of the discriminant is 144 plus 96. That's 150 plus 90, so that's 230. Continuing. The vertex is -3/2 and -17. Of course it is. Line of symmetry, x equals exactly what's there. That's all the line of symmetry ever is, provided you've done everything else right. If you'd made a mistake here and your line of symmetry, you just took what you have here, you're not getting docked for that because it's exactly what you're supposed to do. If these two don't match, then you don't understand the line of symmetry. Maximum or minimum, this is positive. Looks like I gave you guys all positive answers. So it is a minimum of -17. Direction of opening, it opens up. It's positive. Number of solutions. We're moving to the left and then down. So we got 2 solutions again, right? Like if we graph this, it's -1.5 down -17. So it's over here somewhere, but it opens up. There's 2 intercepts, 2 solutions, 2 zeros, 2 roots. There are 2 solutions. Giving myself room for B squared, blah, blah, blah. The discriminant, B squared minus 4AC. B is 12. Who did this? 12 squared minus 4 times A, which is 4, times C, which is -8. 16 times 8. Who did this? 12 squared is 144 plus, what's the best way to do this? 32 times 4, 64 is 128. Let me just double check. 4 times 8. 8, 16, 32, 32, 64, 128. Yeah. So this equals 272. That's the value of the discriminant, which means, and this affirms that we're having 2 solutions. If your discriminant is positive, you have 2 distinct solutions. Maybe something will change with this one. I don't know. I know there isn't a whole lot of room here. The vertex. And by the way, I'm just giving you answers here. I want you to make it a little bit neater. Granted, this isn't the worst. I'm not gonna, the questions will be set up a little bit different too. It's not just this list here and know where to do the work. So just know that. The vertex is 2 and 0. 2 and 0. The line of symmetry, x equals 2. Maximum or minimum? Well, it's positive, so it opens up. So the minimum is going to be 0. Minimum equals 0. Now, if the minimum is 0, that means, what is this, 2? So it's going to be like this, right? So we have 1 double root or 2 equal roots, just saying. Maximum minimum direction of opening, it opens up, opens up. This doesn't look super clear, it bothers me. I don't know if that's any different. Number of solutions. Number of solutions for this are two identical solutions. You could say one double root if you want, that works. If you want to say one solution with a multiplicity of two, that's a bonus mark, considering we don't do marks. So that's the number of solutions, and then the value of the discriminant. I can do that here, b squared minus 4ac. A is 3, B is negative 12, C would be positive 12. We'd have to put it in proper form, right? 3x squared minus 12x plus 12 equals 0. Oh, lots of 12s to work with here. So b squared, b is negative 12, so negative 12 squared, b squared minus 4 times a, which is 3, times c, which is 12. 12 squared is 144. 4 times 3 is 12. 12 times 12 is 144. The discriminant equals 0, which makes sense because we have two identical solutions. That's the first page. Again, please tell me if this helps. For those of you that this doesn't help, then save your breath. But I need to know if I should do this again. If S represents sales for your company and sales depend on the number of units, so S equals U. How many units sold will give maximum sales? When I just said S equals U, I'm just S equals all this. S does not equal U. Okay, don't mishear me. How many units sold will give the maximum sales? So we're looking for a maximum. This is negative, so it's going to have this shape. So we're looking for the Y value. So basically, we can complete the square. S equals negative 3. I'm going to factor that 3 out. Equals negative 3 times U squared minus 10U. Is that right? Because negative 3 times negative 10 would be positive 30. Plus 150. I'm just leaving that 150 alone. I could take a 3 out of it, but honestly, that'll confuse things. We're completing the square, so let's just leave it. Equals negative 3 U squared minus 10U. Negative 10 divided by 2 is negative 5. Negative 5 squared is positive 25. Oh, excuse me. So we just added negative 75, so we need to add positive 75. Negative 3 times positive 25 is negative 75. We've got to do the opposite. So we can't change the value of this. Let's clean things up. U minus 5 squared plus 2, 5. Our vertex, my friends, is 5, 225. 5 is the U. This is max sales. So how many units sold will give max sales? 5 units. Sounds like a poor business plan, but whatever. We're not here to judge. We're just here to crunch the numbers. Solved by factoring. So we're trying to figure out what X equals. We're finding the zeros here. I can't take a 2 out of this because 2 isn't common to all of this, so I just got to do it old school. 2x and x, and then that 3, it's only 3 and 1, or 1 and 3. Both signs can be negative. No, negative and a positive. So it looks like 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. So this works. So this means that x on this case here equals negative 1 over 2. X over here equals 3. You can always test if they work as well, right? So I'll do 3 first. 3 squared is 9. 2 times 9 is 18. 18 minus 15 is 3. 3 minus 3 is 0. The x equals negative a half. That'll take a bit more work probably. I don't think I can do that one in my head. 2 times negative 1/2 squared minus 5 times negative 1/2 minus 3 equals 0. 2 times 1/4 plus 5/2 minus 3 equals 0. 2 times 1/4 is 2/4, which is 1/2. 1/2 plus 5/2. Oh, this works out nicely. 1/2, 5/2. I was thinking 1/5, 1 plus 5 already. 1/2 plus 5/2 is 6/2. 6/2 equals 3. We can see that, right? Checks out. Both of these are good. This one, first I'm going to move everything over. 4x squared minus 4x minus 8 equals 0. We need everything on the same side. Subtracted 4x and 8 from both sides. Now I'm going to take a 4 out of everything. 4 times x squared minus x minus 2 equals 0. And then this gets easier to factor, I hope. X and an x, there's going to be a -2 and a +1. X times x is x squared. 1x and -2x is -x. -2 times 1 is -2. This is why factoring practice helps. X equals 2. X equals -1. We can check. Put in -1 square, so it's 1. 4 equals -4 plus 8, so 4 equals 4. And if it's 2, 2 times 2 is 4. 4 times 4 is 16. 4 times 2 is 8. 8 plus 8 is 16. Both work. When you check your work, if you're asked to check, this didn't ask to check, but you can. This helps you to tell you if you got it right or not. If you are asked to check, don't do what I did. Don't just do it in your head. I can't evaluate that. Cool. Last page. No, 2 more pages. Do I have time? So far I do. Solve using the square root property. So we're isolating the square and then rooting. And it's going to give us a plus or minus. So I'm going to move the 16 over. I'm going to add 16 to both sides. 25 p squared equals 16. I'm going to divide both sides by 25 because I want p by itself. So p squared equals 16 over 25. Oh, look, a couple of squares. I wonder who created this question. Take the root of p. P equals plus or minus the root of 16 over 25. Well, those bad boys both have roots, so that's 4 over 5. So p equals plus 4 over 5 and negative 4 over 5. And like anything else, you can check it. So if I put in 4 over 5, positive or negative, it doesn't matter, because if it's negative, the square will take care of it. So 4 over 5 squared becomes 16 over 25. The 25s cancel, so we have 16 minus 16. That works. I'm not going to check all of them. So here I need to get that e, or at the very least this e minus 3 by itself. Divide both sides by 2. 6 equals e minus 3 squared. Now, if you don't like this, like if you're like me and your brain is more comfortable having this on the other side, that's okay. Flip them. You can just say e minus 3 squared equals 6. That's totally okay. It doesn't change anything. Now we got to get the square root of both sides. And whoever made this test did not give us lots of room here. Is plus or minus the root of 6. We don't have calculators, so we're leaving it like that, and we're adding 3. So it's e equals 3 plus root 6, or e equals 3 minus root 6. You can check these if you like, and it will work. I'm going to keep going. Quadratic formula. Will the quadratic formula be provided for you? Yes. Negative b plus or minus the root of b squared minus 4ac all over 2b. Is it 2b or 2a? It's 2a, isn't it? I have to check. Come on, brain. (2a). Goodness. Good thing I'm giving you the formula because I don't even remember it. So let's put this first into standard form so we can identify easily what's a, b, and c. So we got negative x squared minus 2x, bring the 3 over, plus 3 equals 0. If this bugs you, like it bugs me, divide everything by -1 or multiply everything by -1. X squared plus 2x minus 3 equals 0. I just like this so much better. So a equals 1, b equals 2, c equals -3. Now, if you left it like this, it'll still work out. It'll still work out, provided you don't make any silly mistakes like your math teacher usually does. Negative b, b is 2, negative 2 plus or minus the root of b squared, that's still 2, squared minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a is 2 times 1. Simplify, wow, I really didn't give a lot of room to do work here. So this is negative 2 plus or minus the root of 4 plus 12, so that's 16. Oh, that's nice. All over 2 equals, I'm going to have to use a different piece of paper, negative 2 plus or minus the root of 16, which is 4, plus or minus 4 all over 2. So this equals, you've got two options, right? Because the plus or minus, negative 2 plus 4 is 2, 2 over 2 is 1. Negative 2 minus 4, that's negative 6. Negative 6 over 2, negative 3. And you can check your work. You can throw in 1 into here, see if it makes sense. You can throw in negative 3. One works. I'm just checking my own work here now. Negative 9 plus 6. That's negative. Yep, they both work. Just making sure I'm giving you right answers here. Okay, see if we can fit this one. First, I got to rewrite it. I'm going to rewrite it up here. So we've got negative 2x squared minus 2x minus 3. Okay, as ugly as this is, I'm not going to change the negatives just to show you you don't have to. Ugh, this is going to bother me. Okay, so x equals negative b. B is negative 2. Negative b plus or minus the root of b squared. B is still negative 2 squared minus 4 times a, which is negative 2. So many negatives. A times c, which is negative 3. Good gracious heavens to Murgatroyd. All over 2 times a, which is negative 2. Everything's negative. So we've got 2 plus or minus the root of 4 minus, it's going to be minus. 4 times 2 is 8, times 3 is 24. So this is a negative number under here, which means there's no solutions. You just stop right there. There's no solutions to this. And if you're thinking, how do I know that this is right? What you could do is you could complete the square for this, find the vertex. Let's just do it quickly just to show you. So taking out the negative 2 from x squared plus x minus 3 equals 0. Negative 2 x squared plus x. 1 divided by 2 is a half. A half squared is a quarter. Minus 3. So I subtracted a half. Negative 2 times a quarter is negative a half. So I have to add a half. Equals 0. You don't have to do all this work. I'm just kind of proving something to you here. Negative 2 x plus 1 over 2 squared minus 2.5. I don't like decimals, but I'm rushing here. I've got other stuff I got to do. So our vertex is negative a half, comma, negative 2.5. Okay, negative half. So it's like somewhere down here, and it's negative. It opens down. So correct, there are no solutions. Notice as soon as I realize we have a negative in the root sign, it doesn't work. Oh, goodness. Solve however you want. I'm tempted to do this in all the ways just to show you, but I will be honest, quadratic formula will catch everything for you. You can try solving it normally, but quadratic formula will do it. I'm going to first see if it's just factorable regularly, just for funsies. So I'm going to rewrite this to negative 3x squared minus 6x. I'm going to add 24 to both sides. Factor negative 3 out. So it's going to be x squared plus 2x minus 8. Is that right? Yeah, that's good. Is this factorable? It actually looks factorable. X minus plus 4 minus 2. So this would be 4x minus 2x is 2x, and then -8. Yeah, so x equals 2 and -4. Now, just to show you, is this even on the screen? Yeah. Just to show you quadratic formula, x equals -b plus or minus b squared minus 4ac all over 2a. B is -6, so -6, plus or minus the root of b squared, so it's -6 squared minus 4 times a, which is -3, times c, which is 24. You won't get a number this big. When I make a test for you guys, then I work through it, make sure it works, and make sure you got space, blah, 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 before I format it and give it to you. I'm seeing this right now thinking, this is borderline, because I want you guys to be able to do the math and not get hung up with taking all kinds of space to do long multiplication. Negative times negative is a positive. Whoa, mama, all over 2a. Let's keep some space. A is -3. 6 plus or minus the root of 36 plus 12 times 24, or 3 times 24. What is that, 72? Yeah, 72. 4 times 72, 144, 288. Yeah, I don't know that I would give you this question. Over -6 equals 6 plus or minus the root. What the heck is this? 288 and 36. This would be 294. I can't do that in my head for some reason. 288, 36, 14, 9, 12, 324. Yeah, I wouldn't give this to you. It's too big. 324. All over -6. Okay, but the root of 324, just to prove a point here, 18. See? So it's 6 plus or minus 18 over -6. So we're going to have two answers, right? 6 plus 18 is 24. 24 over -6, -4. 6 minus 18 is -12. -12 over -6, +2. So if it works, it works. In this case, it takes some calculator or painstaking work. So I can't imagine giving you something like this. I want you to be able to do everything by hand and within a reasonable amount of time. I know you guys are smart kids, and you would be able to get to this, but you're probably going to do some trial and error. 17 times 17, 15 times 15, 19 times 19. So anyway, there you have it. One more question. I'm going to get ready for physics. One of the first theaters I ever acted in, true story, during the Fringe Festival has been finally torn down. The building was 3 stories tall, multi-purpose, but the theater itself had 96 seats. Okay, this is not true anymore. I'm just making up numbers. It was also apparently haunted. I've got some stories about that. The number of rows in the theater is 4 more than the number of seats in each row. Okay, so think of it, length times width, kind of an area thing. Length times width, the area is 96. Like if you want to count something, you count the rows, you count the columns. Yeah, maybe I should call them C and R. These are rows and these are columns. So the number of rows, so we know that R times C equals 96. The number of rows in the theater is, as you're reading this, so for some of you that still kind of struggle with the word problems, and I get it, like I have to really slow down, which as you know is hard for me. The number of rows in the theater is, R is the number of rows, equals is your is. The number of rows in the theater, is 4 more, 4 plus the number of seats in each row, 4 plus S. That's the hardest part of any of these questions. The number of rows is 4 more than the number of seats. So because RC equals 96, we know that R, well here, I'll just write it again. RC equals 96. Now I'm gonna, for R, oh, I'm throwing it by columns. It's the same thing. you know, like let's see, you just have. I just want you to know why I'm interchanging this, because it's just going to be easier, because the question says seats. I went with columns. So let's say these are rows. You have 4 rows, right? And then you've got 1, 2, 3, 4, 5 columns. You've also got 5 seats per row. So it's the same thing. I don't want to throw anybody or confuse anyone. Okay, works out the same. So 4 times 5 is 20. There are 20 seats here, 5, 10, 15, 20. Okay, so that's, I just wanted to clarify that. So R times S equals 96. We know that R equals 4 plus S. So 4 plus S times S equals 96. Simplify, oops. 4S plus S squared equals 96. I think you know where we're going with this. I'm going to move this around a little bit. S squared plus 4S minus 96 equals 0. So now I'm going to factor it. We're solving for S. Determine the number of rows. Yeah. Okay, so we're solving for S, which is fine. That'll give us to R. So S and S. This is going to be a positive and a negative. 96. That's 2 times 48, or is 3 going with that? Yeah, 3 times 32. We need a difference of 4. 4 times 96, that's 48. 24, 4 times 24. 5 won't go into that. 6 go into that. 2 and 3 have to go into it. So yes, 6 times 16. So that's a difference of 10. 8. 7 won't go in there. 8. 12. There we go. 8 times 12 equals 96. Plus 12 minus 8. S equals either negative 12 or positive 8. It can't equal negative 12. We can't have negative 12 seats. So if S equals 8, then R equals 8 plus 4. And you can try it. 12 times 8, 96. That's how many seats there are. It works. Determine the number of rows and the number of seats in each row. There's 8 seats in each of the 12 rows. Oh, how much was I moved over for? Not on the screen. Technology. Can I blame technology? It's my fault. Hopefully that makes sense, my friends. Do tell. Well, if you're looking at this, so this is going to be a bit tweaked. Might as well cover this real quick. Factor polynomial. Yeah, this is not a main outcome, but yeah, you're gonna have to know how to do that. Factor polynomial with the expression. This is a maybe. This is a difference of squares, like x squared minus 4 equals 0. Correct examples or correct errors in an example of completing the square. I don't see that happening. Solve determining roots, factoring, completing square. Yeah, all that. This is kind of, it's not going to be explain, but you are going to use the discriminant. It'll be very similar, if not almost identical to this. I just realized I switched to the red for one part of it and then just stayed with red. But anyways, it'll be very close. Not identical, obviously. I got to give you something different, but hopefully that makes sense.